I'm using LeaveOneOut cross-validation, a method where I test a model's performance on a dataset with 10 samples. Each sample gets its turn as the test sample one at a time, while the rest become the training set. That's the core idea. This is a multiple-choice quiz question testing your understanding of LeaveOneOut cross-validation and its implications for the number of training and test sets. I think it will be fun. The question sets the stage. I'm using Sklearn, SLEAVEONEOUT method with 10 samples. We need to find out how many training and test sets this will generate. This statement claims there will be 10 training sets. Let's see if this is true. Each training set would have 9 samples because the total is 10. 10 minus 1 equals 9. And 1 is left out as the testing sample. 10 testing sets each with 1 sample. This makes sense given the LeaveOneOut method's design. Each sample has a turn. This is a distractor. LeaveOneOut doesn't create 100 splits. It's way more efficient than that. It would create only 10 splits. This is a key characteristic of LeaveOneOut. Every sample takes a turn to be in the test set. This is just a reminder. We're working with a dataset containing 10 samples. This section helps us visualize how the process works. The LeaveOneOut method runs through the dataset sample by sample. The LeaveOneOut method does 10 iterations, one for each sample in the dataset. In each of those 10 iterations, I have 9 samples used for training. I'm using the LeaveOneOut cross-validation technique, a method where I take a dataset, in this case, one with 10 samples, and systematically test the performance of a machine learning model. I'll do this by creating many different training and testing sets. It's like repeatedly giving your model a pop quiz. I've got a dataset, it's a collection of 10 data points, and I want to make sure my model can accurately predict outputs given new data points. Here's the core of the problem. I'm using Scikit-learn's LeaveOneOut, LeaveOneOut, method to check how well my model performs. Scikit-learn is a popular Python library for machine learning. LeaveOneOut is a specific way of splitting data into training and testing sets that ensures I use each sample exactly once for testing. I have 10 data points and want to know what happens when I use LeaveOneOut. With LeaveOneOut and 10 samples, I create 10 different training sets. Each set contains 9 samples because one sample is held out for testing. Think of it like this. I have 10 students, and each time, I let one student sit out for a test while the other 9 are the training group. Since I have 10 samples in total and each is used exactly once as a test sample using LeaveOneOut, there are 10 testing sets, and each contains only a single data point. This is a direct consequence of using LeaveOneOut. This is the defining characteristic of LeaveOneOut. Each of my 10 samples gets its turn as the test sample, and it's only used once. That's the beauty of LeaveOneOut. This is incorrect. With LeaveOneOut, the total number of training, testing splits is equal to the number of samples, which is 10 in this scenario. 100 splits would occur using different cross-validation techniques. I'm using LeaveOneOut cross-validation, a technique where I take a dataset, in this case, one with 10 samples, and systematically evaluate a machine learning model. In each iteration, I leave out one sample for testing and train the model on the remaining 9 samples. It's like testing a student on different questions from an exam one at a time. This is simply the set of data I'm working with. Think of it as 10 different exam questions. This is the specific cross-validation strategy I'm employing. The abbreviation, LeaveOneOut, is quite common. It ensures every sample in my dataset gets a turn as a test sample. In each iteration of LeaveOneOut, I train my model on 9 out of the 10 samples. That's why I have 10 different training sets, each with a slightly different composition. It's like giving a student 9 out of 10 exam questions to study. With each training set, I'll have a corresponding test set, and this contains only the single sample I left out of the training set for that iteration. I'll test the model's ability to predict the outcome for just this single sample. It's like asking the student to answer the one remaining question they haven't seen yet. I'm using the LeaveOneOut cross-validation technique, which is a special way to test a machine learning model. I have a dataset with 10 samples. This technique will help me evaluate how well my model performs. It does this by testing the model on each sample individually, while using the rest as training data. It's like giving your model a pop quiz on each individual question. Because I have 10 samples, I'll create 10 different training sets. Each training set will have 9 samples, all except for one sample that will be held out to test the model. Imagine you're teaching yourself multiplication. You practice many problems to learn and test your understanding. 9 out of 10 problems will be used to study, and 1 to test your knowledge. I'll also have 10 different testing sets. Each testing set will contain only one sample, the one held out from the corresponding training set to test the model's prediction. We're carefully testing our model after training on the other data. This is like only testing your multiplication skill with only one problem you've never seen before. With 10 samples, the process will run 10 times. In each run, I leave out one sample for testing and train the model with the remaining 9. We repeat this process 10 times, testing the model's ability to predict correctly each sample. We're using a specific type of cross-validation called LeaveOneOut. Imagine you have 10 data samples. LeaveOneOut means we'll test our model 10 times. In each test, we leave out one sample for testing and use the remaining 9 samples for training the model. That's it. Pretty straightforward, right? That's correct. Because we have 10 samples, and in each of the 10 iterations, one sample is held out for testing, the training set will always consist of the remaining 9 samples. So, I'll have 10 separate training sets of 9 samples each. Think of it like this: 10 different training sessions, each with 9 students. This is also true. In each of the 10 tests, only one sample gets to be the test student. So we'll have 10 test sets, each with just one sample. Each sample takes a turn in the testing spotlight, one at a time. Nope. We only have 10 samples, so we only need 10 iterations, each leaving one sample for testing. 100 splits would be way too many for this. Absolutely. That's the whole point of LeaveOneOut. Every sample has its moment to shine as a test sample, ensuring that every data point contributes its fair share to the evaluation. This makes LeaveOneOut really comprehensive, right? It's like everyone in class getting a turn to present their project. I'm using the LeaveOneOut cross-validation, LOOCV, technique. LOOCV is a special type of cross-validation where I take each sample from my dataset and test my model on it one by one, and train my model on all the remaining samples each time. Think of it like this: I have 10 cookies. Each time, I pick one cookie to taste, testing, and I use the other 9 cookies to decide how yummy my cookie recipe is, training. Since I have 10 samples, I will do this process 10 times. I start with a dataset containing 10 samples. Let's say they are 10 different measurements. Think of these samples as 10 different houses which I have to determine their valuation. Because I have 10 samples, I'll run the LOOCV process 10 times. Each time, I'll pick one sample for testing and train the model on the rest. This is why we refer to this method as exhaustive. Each sample is tested exactly once. I'm emphasizing this because it's fundamental to how LOOCV works. I'm using scikit-learn's LeaveOneOut function, which implements the LeaveOneOut cross-validation method. This is a very powerful technique to test how a model performs when there is a limited dataset. I'll get 10 separate testing sets, each containing only one of the 10 samples from my dataset. That's because each time I am taking only one sample to test my model on. I want to make sure every sample gets its chance to be a test sample. That's the whole point of LOOCV. LOOCV guarantees this. I will also have 10 training sets, each time with 9 samples. Because I will use all the remaining 9 samples to train my model when I hold out a sample for testing. This is incorrect. I only have 10 samples, therefore, I would only have 10 training and testing splits, not 100. 100 splits would be like if I was doing 10-fold cross-validation, not LOOCV. That's a very different process. I hope this makes sense. This is the problem statement. Given 10 samples and using LOOCV, I need to determine the number of training and testing sets generated. I can solve this by understanding the fundamentals of LOOCV.